Hello, this will be a demonstration of proposition 33 from book 3 of Euclid's Elements, which requires us to, on a given straight line, describe a segment of a circle admitting an angle equal to a given rectilineal angle. This language of admitting, all that it means is that the angle in this segment must be equal to the given rectilineal angle. What we are given is the straight line AB, on which it is required for us to describe the segment, and we're given some arbitrary rectilineal angle C. And given these, we must, on the given straight line AB, describe a segment of a circle admitting an angle equal to the given rectilineal angle C. Now this angle C can either be less than a right angle, acute, it can simply be a right angle, or it can be greater than a right angle that is obtuse. Let's first deal with the case where the angle C is less than a right angle, and so the angle C is acute. And if this is so, we begin by drawing the angle BAD at the point A equal to C. We'll draw this out like so. So we know that the angle BAD is equal to the angle C, like so. Excuse me. Next, we draw the straight line AE perpendicular to AD at the point A. We did this by proposition 111, right? Next, we bisect the straight line AB at the point F. So we know that AF is equal to FB. And finally, from the point F, we draw the straight line FG perpendicular to AB. So these are right angles. That's also a right angle. And the final thing we do is we connect the straight line GB. Like that. Okay. It's actually not connected. That's better. Okay. Now, in these two triangles, AFG and BFG, we have two sides equal to two sides, and the angle contained by the equal sides equal as well. Because we have AF equal to FB, we have the common side FG, and we have the angle contained by these equal sides equal as well, right? Because the angle AFG has to be equal to the angle BFG. These both are right angles. In postulate 4, all right angles are equal. And so these two triangles by proposition 1 and 4 must be equal in all respects. And so we know that AG must be equal to GB. And because AG is equal to GB, we know that if we describe a circle with the center G and the distance GA, the circumference of that circle must also pass through the point B. This follows from definition 115. And so let's actually make the circle now. We'll make the circle ABE, like so. And we'll move E up here. Okay. Excuse me. Final thing we do is we join the straight line EB, like so. Let's postulate 1 again. Now, this angle here, DAE, being a right angle, we see it that the straight line AD is perpendicular to a diameter of the circle ABE at one of its extremities. So we have the diameter AE. We know that AE is a diameter because the point G is on it and G is the center. And we have AD perpendicular to this diameter at one of its extremities, namely the point A. So the porism of proposition 316 tells us that this straight line here, AD, must be touching the circle ABE. Now, because it is touching the circle, we can leverage the previous proposition, 332, and say that the angle here, DAB, must equal its angle in the alternate segment. The alternate segment being the segment AEB, and the angle in this alternate segment being the angle AEB. And so the angle DAB is equal to the angle AEB. We also made the angle DAB such that it is equal to the given rectilineal angle C. So common notion 1 tells us that the angle AEB is also equal to the angle C. And what we have now is a segment of a circle AEB described on the given straight line AB such that the angle in this segment is equal to a given rectilineal angle C. And this being what we set out to do, we are done with the construction. However, the angle C does not have to be less than a right angle, so let's move on to the case where it simply is a right angle. We'll draw C like so. C is a right angle this time around, and we have the straight line AB like so. Now, if the angle C is a right angle, we begin by drawing the angle BAD at the point A equal to the the angle C, so the angle BAD here, also a right angle. Next, we bisect the straight line AB at the point F, so AF is equal to FB. And finally, we describe the circle AEB with the center F in either the distance FA or FB. FA and FB are equal, so it doesn't really matter. So let's make this circle. And we'll call this circle AEB. And we'll end this by simply drawing the straight lines AE and EB. We can do this obviously by postulate 1. Now, we know that the angle BAD is a right angle because we made it equal to a right angle. And we also can see that the angle AEB must also be a right angle. We know this by proposition 331 because this segment of a circle here, AEB, is a semicircle, right? Because it's cut off by the diameter. So I'm going to turn the lights back on. There we go. Okay, so this segment here, AEB, is a semicircle because it's cut off by a diameter. And we know, again, by proposition 331 that the angle in a semicircle is a right angle. This angle AEB is also a right angle. And postulate 4, again, allows us to say that the angle DAB is equal to the angle AEB for both are right angles. And we also know that the angle DAB is equal to the given rectilineal angle C. We made it that way. So common notion 1 tells us that the angle AEB must also be equal to the given rectilineal angle C. And what we have here is a segment of a circle AEB such that the angle in it is equal to the given rectilineal angle. And this segment AEB has been described on the given straight line AB. And this is what we set out to do. So we are done with this case where C is a right angle. Now let's move on to the final case where C is greater than a right angle, where C is obtuse. So we'll have it looking like that. And we'll have AB like so. Yeah, not like that. Okay. Now, if the angle C is an obtuse angle, we again begin by drawing the angle BAD equal to the angle C. We can do this by proposition 123. Next, we draw the straight line AE perpendicular to AD from the point A. We do this by proposition 111. Again, we bisect AB at the point F, so AF is equal to FB, like so. And again, we draw the straight line FG perpendicular to AB from the point F. We can do this by proposition 111 again. And we end by drawing the straight line GB. Okay, very similar to the first case. Now, similar logic tells us that because AF is equal to FB, the straight line FG is common, and the angle AFG is equal to the angle BFG, again, because they're both right, in postulate 4, all right angles are equal. In these two triangles, we have two sides equal to two sides, and the angle contained by the equal sides equal as well, and so these triangles are equal in all respects, namely that GA be equal to GB. And again, if we draw the circle with the center G and the distance GA, we know that the circumference of the circle will also pass through the point B. That's by the definition 115 again. So let's make this circle AEB with the center G and the distance GA. Okay. We'll move the point E up here again. Okay. And we end this by drawing the straight line. No, never mind. We have the point H right here. This is between the arc AB, and we'll simply draw the angle here. So we'll draw the straight lines AH and HB. Now we know that the angle DAE is a right angle because we made AE perpendicular to AD at right angles from the point A. So this angle DAE is a right angle. And being a right angle, again, by the porism of proposition 316, we know that this straight line AD must be tangent to the whole circle AEB. And being tangent, we can leverage, again, proposition 332 and say that the angle DAB is equal to its angle in the alternate segment, namely AHB. So the angle DAB is equal to the angle AHB. And we also know that the angle DAB is equal to the given rectilineal angle C, because we made it that way. So common notion 1 tells us that the angle AHB must also be equal to the given rectilineal angle C. And we have actually done what we set out to do. We have this segment AHB described on the given straight line AB such that the angle in this segment is equal to a given rectilineal angle C. Now this is the final case of the angle C which we must deal with, and so we have successfully done what we set out to do, which means we are done with the proposition QEF. I have nothing to add to this proposition, so I will move on to 334.